Okay, good morning, students. Am I audible? Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, fine. So, in my last class, yesterday class, I was discussing something about the origin and occurrence of the groundwater. So, today we shall try to finish it off. And from next class, we are going to start on the different concepts of the hydrology. Okay. So, now, as you already know, what is the importance of groundwater? Why should we study the importance of the groundwater? Why should we study the groundwater? Okay, so groundwater is the one which is very useful. Okay, apart from the surface water, every now and then you cannot depend on the surface water for your existence. Okay, ancient nomadic man always depended on the surface water itself. So that's why you can see the Harappan civilization and the Mohenjo-daro civilization, the Egyptian civilization, all those civilizations flourished near the water source itself because our ancient man knew the importance of water. Even today, you can see many civilizations which have flourished have been very closely affiliated with the water source itself. Nearby the Sindhu River, it may be near the Nile River or Amazon River, anything like that. Okay, so all the ancient human beings settled themselves near the water source because of the importance of the water. On the coming days, what happened was the surface water started to deplenish, or it started to disintegrate, or it started to go off. What happened was, as the time progressed, when there was a lot of the other activities, so the groundwater pollution and also the surface water pollution, the surface water diminution started to take place, which means the perennial rivers started to flow only in the seasonal time. Okay, the perennial rivers now, from many years ago, you can say many years ago, the rivers were very perennial, which means to say they used to flow all through the year. But coming days, what happened was, you can see the Tunga and the Bhadra rivers itself, they are not perennial, which means they do not flow at their very full levels almost all the year. Okay, only in the season, that is in the parts of the rainy season, you can see the Tunga and Bhadra rivers flowing to their full level, full extent. Okay, which indicates that the perennial rivers started to become seasonal. That's why that was the time when the man started to rely on the groundwater sources. Okay, until then there was no uses of the groundwater, but it was that time when the man came to know that the rivers were not perennial. It became seasonal. For the rest of the year, or the part of the year, rest of the year, they started to rely on the groundwaters. So that's why this groundwater became of utmost importance. Okay, you can see that every now and then a borewell is being drilled once in a day. In a day, all the 365 years, if you go and looking any part of Shimaga or Bhadragi or any part of Shimaga district, you can see one borewell will be drilled at least a day. This is the importance of the groundwater in today's level. Okay, so that's why the judicial use of this groundwater is very important, because you cannot expect the groundwater to be occurring every now and then. Okay, only if the groundwater is being recharged, then you can start to use them. Otherwise, if the recharge of the groundwater is not done, then the usage of the groundwater is also not possible. Okay, if you recharge your mobile phones itself, if you plug in the battery source itself, your mobile will be on for the day. Otherwise, if the battery dies, then you cannot use your mobile unless and until you charge it. Similarly, if you don't recharge the groundwater, then you cannot use it by the next generation itself. Okay, so the groundwater levels has almost gone down in today's day. The groundwater levels has almost gone down. For one time in Shimaga and parts of Shimaga and Bhadravati, if you dig 200 to 300 feet, you could have expected good groundwater. But now, if you dig around 600 to 700 feet, you may not expect too much of the groundwater in parts of this Malnad itself. Then you take the example of the other places. So that's why judicial use of this groundwater is of utmost importance. Now, what are the sources of the groundwater? When we see the sources of the groundwater, so first one is the meteoric water. Meteoric water is the water that originates from the atmosphere, which comes directly from the atmosphere, directly through the form of precipitation. In my last class itself, I told you different forms of precipitation. You got the thunderstorms, you got the hail, you got the snow, you got the dew, you got the fog, you got the rain. All these become sources of the ground or precipitation. These are the different forms of precipitation which are being entangled together. Okay, so originally the water that comes from the precipitation, it may be in the form of snow or ice or dew or fog or rain. All these become sources of the groundwaters. Okay, so they become the meteoric water. Okay, that water which being originated from the atmosphere, it starts infiltrating through the zone of saturation and become a groundwater in the aquifers. Okay, so this is how the meteoric water is being originated. Okay, you can see the clouds bear the rains, and you can see some of the snow that has been dominated, and it has been it has disintegrated. The snow has melted down to form the water. Okay, they all recharged into the groundwater levels. Okay, they start infiltrate into the ground systems and becomes the sources of the groundwater. Okay, so next is the magmatic water. Magmatic water is a water, or the juvenile water is that water which is called youth. Okay, juvenile means juveniles, which is youthful. Okay, rejuvenation. Juvenile water is a new water or the derived water that is being formed from the deeper part of the earth, which has not appeared on the earth's surface or circulated in the atmosphere. See that the water that is descending from the atmosphere becomes the meteoric water, but these juvenile water or the magmatic water are the waters that are being coming from the deeper parts of the earth. Okay, like the core levels or the mantle wells. Okay, the water that originates from the core levels or the mantle wells, because of the heat that is present in the interior of the earth. Okay, you know that earth interior has got around a 6000 Kelvin temperature. Okay, 6000 degrees of temperature in the earth's center core. Okay, so because of that enormous amount of heat, there is some amount of fluid that is being released. Okay, that fluid will be in the form of water, which is not found from the atmosphere, but these are the waters that are being found from the inner part of the earth. Okay, so they are the fluids that are which is derived from the magma. Whenever the magma is erupting, you know that there is lot amount of fluid, just like our body sweats or perspires. Sweating is a phenomenon of the body, human body. Similarly, rocks also sweat or perspire. Okay, when the rocks perspire or sweats down, there is lot amount of new water that is being released. Okay, they become the juvenile water. Okay, so they are called as hydrothermal fluids, which are being released from the magmatic crystallization or solidification of the rocks from the earth's crust. Okay, so you know that these are the hydrothermal fluids which release the waters. Okay, so these are the new waters that are being released. So coming to the metamorphic water, metamorphism is a process by which conversion of structure and textural changes takes place in a rock without undergoing melting. If a rock undergoes melting, then it is called anatexis. If a rock undergoes changes without any melting, without undergoing melting, only the structural and textural changes take place, then those processes are called as metamorphism. Okay, so during the process of metamorphism also, a lot of structural and textural disintegration or decomposition or differentiation take place, during which the rocks will lose some of the interstitial waters which is present within them. So that water are called as a metamorphic waters. Okay, so during the structural and textural changes that is being attributed to the rock, they undergo changes which will cause the waters to be released. They are called as a metamorphic waters. Okay, so connate water. So what are the connate waters? During the time of sedimentation. Sedimentation is a process which is formed from sedimentary cycle. Okay, sedimentation cycle. Okay, if the rock undergoes weathering, transportation, erosion, transportation, and deposition, during that process of sedimentation, what happens is there are a lot of waters that are being trapped in the pores of the rocks. There are a lot of waters that are being trapped in the pores of the rocks. Okay, So these are the liquids that are composed of waters. Okay, so that's why what happens is these waters are found between two rocks that are being sandwiched. You know, between two rocks, if a layer of water gets sandwiched, what happens is because of the underlying pressure and the overlying pressure, there are a lot of fluids that are being released. The water starts to expel out from the sediments because of the overlying pressure and the underlying pressure. Because of the underlying pressure and the overlying pressure, whenever the rocks are being compressed, a lot of amount of fluids are being squeezed out from the spaces that are being available to the rock. Okay, so those waters are called as a connate waters. Okay, you know, these are some of the water bearing fluids. When they are being broken down, what happens is the waters are removed from the interstitious spaces. Okay, so oceanic water, you know, water occurs in the oceans due to density variation. It floats on the fresh water, and also if well are dependent near this coastal region, then well water becomes saline water. So that process is usually called as a marine transgression. Okay, the sea water mixes with the fresh water. So this happens in the Mangalore zone. Okay, anybody from Mangalore, they have experienced these things because during the rainy season, what happens is the water from the well starts to come up. Okay, because of the underlying pressures. Okay, so if the amount of the rainwater gets mixed with the salt water, ocean water, then ocean water sometimes what happens is it gets mixes with the well. Okay, so that time what happens is the fresh water also gets converted into the saline water. Okay, so this is also a common phenomenon that is called found in the places near the seas. It is called as marine transgression. Okay, so what are the occurrences of the groundwaters? So you know, the rainfall that percolates below the groundwater surfaces that passes through number of layers that and the rocks between the spaces of the rocks, which is called as voids, and joins the water table. So what happens is these voids or open spaces are usually interconnected, which allows the movement of the groundwater. So that's why they become interstitial spaces. Okay, so the water storage capacity of the groundwater is always dependent on the porosity of the rocks, the rate at which it is added by infiltration, and also rate at which the water is lost by it from evaporation, transpiration, seepages, and also by withdrawal by the man. Okay, now let us look at the porosity and permeability. What is porosity? It is number of voids which is present in the rock, that is the pore spaces or the open spaces that is available for the rock for the free movement of the fluids within them. Not only the waters, all the fluids to be moving through them very freely, those are called as voids. Okay, so it is usually given by total saturate sample of the dry volume to the total volume of the rock. Okay, wet volume by the dry volume into 100 gives the porosity percentage. Okay, we can see the porosity levels. Okay, if you can see here, it is there is having lot of open spaces or interstitial spaces. You can see these are called as a interstitial spaces, which is being found within the rocks or the fragments they have been combined together. Okay, these are the minute openings that are available within the rock through which free movement of the fluid can take place. Okay, so in this case you can see the voids are completely filled. That's why the open spaces are very less or minimum in number. That's why the free spaces is not available. The free movement of the liquid is also not possible. Okay, so these are different types of the rocks from which you can expect the porosity. If it is comprising of granite and quartzite, it is having 1.5 porosity. That's why the parts of Chitradurga and Hasdurga do not get groundwaters at very easy levels, because the infiltration itself is very difficult, because granite usually do not possess so much of voids or opening spaces or open spaces available for the free movement of the fluids. If the free movement of fluids is not possible, then you can expect least amount of water to be recharged into the ground system or the water table. If the recharge is not possible, then you believe me that the groundwater capacity also diminishes. Okay, so that's why you can see in the fort there is one place called Akkatangi Honda and Gopal Swami Honda, which acts as a water storage units. Okay, and that was built by the ancient man in Chitrurga, that is Nayakas of the Chitrudurga. They knew the importance of waters because they knew that there was there was no amount of water that should be available. That's why and that served as two purposes to the people over there. The Gopal Swami Honda and the Gopal Swami Honda and the Akatangi Honda served as a rainwater harvesting system also, and also water purification also took place from both of them. Okay, whenever through there are some channels that are being present, and water from the direct water from the rainfall used to get collected in the Gopal Swami Honda, and water started to purify through the layers, and it used to pass to the Akatangi Honda, and from there it is used to pass to the Seniru Honda. Okay, that's why it is called as Sihiniru Honda, which means you could get very good drinking water at the bottom of the fort. Okay, so you can see Gopal Swami Honda is at the topmost level and the Sihiniru Honda is in the bottommost level, which means to say it served as a filtration process also. Okay, apart from the storage of water, it also served as a filter. So you can see slate and shale, they expect have 4% porosity. Limestones has got 5 to 10% porosity. Sandstone has got 10 to 15%. Sand and gravel has got maximum 20 to 30%. Only gravel 25%. Only sand 35%. And clay and soil has got 45% of the porosity within them. Okay. Now, apart from the primary porosity, there is one more called as secondary porosity, which can be found within the interstitial spaces that is found in the rocks. Okay, so these are the secondary porosity levels from which the water can be moved through the openings that is available within the rock. Coming to permeability, porosity and permeability are different. Porosity is the number of void spaces present in the rock, which helps the free movement of the fluids, whereas permeability is a measure to which the pores are interconnected and the size of interconnections. What is the diameter of the connections, open spaces, and what is the size of the interconnections? Okay. Low porosity results in low permeability. High porosity always imply high permeability. Okay, a good rock with a high porosity will have a low is called as a vesicular volcanic rock. You can see how porosity and permeability gives rise to the rock. Okay, if there is no spaces, then there is water cannot flow through them. Unconnected pore spaces, then it cannot pass through one pass to another. Okay, it is porous, but it is non-permeable. If it is connected pore spaces, then both porosity and permeability will be available. Okay, you can see here different types of permeability. If it is only gravel, then what happens is it starts to drain off. Okay, if it is for 2 minutes, you cannot if you hold the water, you cannot hold the water in gravel for not more than 2 minutes. But in sand, you can hold the water for 20 minutes. In silt, you can see for 2 hours the water level remains the same. And if it is clay, then water level can stay up to 2 days. Okay, that shows the different levels of permeability. Okay, so you can see different types of soil composition and what is the flow times that is required, and what is the water required in ml, and what is the permeabilities. Okay, if it is pebbles, then 7.5 seconds is the time. So 43 ml of water is being recovered out of 50 ml or 100 ml. So which means to say 5.73 ml of per second is being permeability. If it is pebbles, for 10 seconds, you can see 40 ml water is being recovered out of 100 ml, of which 4 ml can be found out. If it is sandy clay, around for 600 seconds, that is 6 minutes, you can see 0 water is being recovered. Clay loam, you can see for 600 seconds or 60 minutes, 6 minutes, you can see 0 ml of water is being. For sandy loam, it is for 65 seconds, 40 ml of water is being. Sandy loam again, 47 seconds, you can expect 30 ml of water. Sand, 490 seconds, 10 ml of water is being recovered. And for sand, for 225 seconds, you can expect of 20 ml of water. Okay. So what is the distribution of the groundwater? So how the water is being distributed gives the water table. Okay. It is usually considered to be the lower surface of the zone of suspended water to the upper boundary of the zone of saturation. from the bottommost layer of the water table to the zone of saturation is called as a water table. Okay, it is defined as a contact plane between free groundwater and the capillary fringe. Okay, so what happens is water table usually fluctuates with the weather conditions. Okay, and also it depends on the topography of the region also. The water of saturated zone is usually denoted as groundwater or the phreatic water. Usually the water which is found in the saturated zones is usually called as a groundwater or a phreatic waters. Okay, so this itself is called as a distribution of subsurface water. You can see this ground surface below which you can find the soil water zone. Okay, that is the water that is obtained from the soils. The soil usually has got some amount of moisture within them, which is called as a soil water zones. Okay, so from ground surface up to the water table, topmost layer of the water table is called as a water zone, that is zone of aeration, and below the water table up to the impermeable rock is called as a zone of saturation. Okay, impermeable rock means it becomes a foundation or the basement to the groundwater, below which no water can percolate. If it encounters an impermeable rock, then if this impermeable rock comes on top means then you cannot find any groundwater. If this impermeable rock comes at the bottommost layer itself means you can find some groundwater because it acts as a boundary or compound or basement. Okay, so up in from the water table you can find the capillary zone, and from water table, from top of the water table to the impermeable rock is called as a zone of saturation. You can find two zones, one is zone of aeration and another one is a zone of saturation. Okay, so with which I'm going to conclude my topic today. If you have got any questions you can ask me now. If you have got any questions you can ask me. No questions. Okay, drop in your attendances now. We shall continue our discussion next class. Thank you.